asked for the maximum kinetic energy, so Ke ang hinahanap, that was released no when a metal was irradiated with 279 nanometers of light. Okay, rubidium, this is your work function no, needs 208.4 kilojoules to remove 1 mole of electron. Okay, your composite video and try answering. So this is how you answer your rubidium, no? So what is the maximum kinetic energy that was released during this irradiation? So you equate your photoelectric equation in favor of your kinetic energy kasi si kinetic energy ang hinahanap or the maximum kinetic energy. You replace your E total with this equation right here, your Planck's constant times your speed of light over your wavelength, okay, minus your work function. Okay, your work function is actually mentioned in the problem. Okay, so you have your Planck's constant. Remember that it is per electron. You have your speed of light and your wavelength. Okay, your wavelength is in terms of meters, no? To accommodate your meter per second sa imong speed of light minus your work function. Okay? Your work function is actually per mole electron. So, dapat meron kang mole electron here. Joules per mole electron. Okay? So how do we convert 1 mole of electron um, to a specific number, no? To electron lang. You actually use the Avogadro number, no? So 1 mole of electron is equivalent to 1 Avogadro electron. So 6.02 times 10 raised to 23, diba? Okay. So 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 you can cancel out mole per electron and you are left with electron na lang na. Okay. So from here, you can actually combine this one since same na sila, joule per electron. So joule per electron is actually the kinetic energy or the maximum kinetic energy release, okay, during the irradiation. So if you want to convert back to kilojoule per mole electron, then you need to multiply it for the conversion unit of mole to your electron, no, which uses your Avogadro number. So if this one cancels out, you would have your kinetic energy in terms of kilojoules per mole electron. Okay. All right. So that is for your problem. Okay. So if hindi nakuha, try again. And try to answer again no, um without looking in the screen. Okay. Okay. Dati, science taught us that electrons are actually particles no? Kaya nga siya tinawag yung subatomic particles, no? Such as your neutron, proton, and electron. No? However, it was soon discovered that electron could actually behave as a wave. And the experiment was done and validated by Louis de Broglie. No? So, actually, some teacher call it de Broglie. But in French, though, they say it as de Broglie. Okay. It is actually seen in the double slit experiment now. So if light is shown in double split panel, there would magkakaroon ka ng constructive and destructive interference, no? If you have a here spectra having more light in it here, then actually this is a constructive interference, no? So walang cancellation of waves, but the dark ones here are destructive, meaning this is actually a property of light. No, light behave as a wave, hence magkakaroon ka talaga ng constructive or destructive interference when it is shown or shine in a double split panel. Okay, so this is an example of light behaving as a wave, but electrons, when experimented in the same environment, electrons are actually able to behave no constructively. So, proving that electrons could behave as a wave because meron kang constructive interference here or a region where most of your electrons are seen, no? So meaning if your electrons are destructively um when electrons was shown no in this panel, may tendency siya na magkaroon ng constructive interference and destructive interference, no? So the front view of this experiment shows that both electrons are seen in this side, no? Meaning meron kang constructive interference mimicking a wave-like property, no? So this proved that electrons could actually behave as a wave. So now that de Broglie was able to prove that electrons could behave, as a matter of fact, as a wave, um, he then suggested that electrons moving around the nucleus of an atom behave like a wave and therefore has a wavelength. Okay? May wavelength daw ang electron. He proposed that the wavelength of an electron or any other particle depends on its mass and velocity. Okay? So paano niya nakuha ang equation na to? He actually uses two equations, established equation in physics, the one correlating your wavelength to your energy and your mc squared of Einstein, matter and energy and speed of light. Okay, you use these two equation and derive it your um wavelength, no? Wavelength, no? So your wavelength is actually correlated to the cm, which is actually pinalitan niya ng mass and velocity. Okay, proving that an electron having a mass could have a wavelength, no, and a wave-like characteristic or property. Okay, more on that, as you can see here, if you're familiar with your physics, no, physics in undergrad, no, your mv is actually your momentum, so the Broglie equation could actually be written in this form, no? So Planck's constant over the momentum. Um, Note that the v here is not actually the frequency na, it's actually your velocity because you're defining electron as a wave using the Broglie equation. No? So Planck's constant, mass, and the velocity equals the wavelength. Okay, so you remember the equation for the Broglie. Okay, so when we imagine an atom, we often imagine the Bohr model now. So electrons circle um, orbits around a allowable circular orbit around your nucleus, now where your nucleus is contains your neutron and your proton. Okay, but actually electrons move in 3D, no? Kaya nga yung orbit pinalitan ng orbital, okay? Giving a electron probability density at a certain period of time now. So you cannot actually draw it like this because you can actually um say the exact position of your electron, no? So the more perfect or the more established model for your electron or your atom is actually this electron probability density. Okay, you would have your 2s, di ba? S is spherical, so you have your spherical shape loops, no? Loops of electron density, your 2p orbitals, and your nucleus here. Okay, so pag madami kang orbital, then magsasama-samang orbital, mag-overlap sila. Okay, so you should try to imagine your atoms or atomic model similar this quantum model na, okay, in 3D. Okay, more on your quantum model, hence your quantum number, no? So, quantum mechanical model. It describes the property or probability of finding an electron in a 3D space based on the mathematical function or your wave function, no? So orbitals are the region spaces where the probability of finding an electron is relatively high, which is called their orbital. They are visualized based on the wave function. Okay. Actually, if you squared your wave function, then you would get the probability of finding an electron. Okay. The characteristic of an orbital, shape, energy level, and orientation are determined by the set of quantum numbers. So quantum numbers is basically the address of your electron, no? The most probable address of your electron at a certain period of time. Okay, so this is actually your S, quantum number or L, angular momentum, no? So L pertains to the shape of your orbital. So S is for sphere. You actually have here a region of high electron density, yung maliwanag, or the shiny ones, no? And a region without zero probability of finding an electron, or the dark region here circling around the center. Now, these are actually your nodes. Okay, nodes. Meron kang, I can't really type. Basta nodes niya siya. Okay, nodes. Okay, so this is your P orbital having a node dito sa gitna and high electron probability dito. Okay, magkabilaan. All right. So this is actually, so they could actually be a 3s, 2s, 1s orbital, and 2p, 3p, no? And you actually have your 3D here, no? So madami ka ding nodes dito. Okay? Though the dark part are actually your nodes. Okay? Nodes are region spaces where the electron probability of finding an electron is zero. Okay? So, okay, so more on that. So here, okay, quantum mechanical model. Um, Due to the spatial arrangement of electrons in space, we need something to describe its position and energy. Hence, we need a set of quantum numbers. Okay, we actually have four quantum numbers: your principal, azimuthal, magnetic, and spin. Okay, um, azimuthal could actually pertain to angular momentum, no? In some books. So you have your principal, which accounts for the main energy level, or shell, or the distance of an electron from a nucleus. This could be 1, 2, 3. Okay? So these are your counting numbers, 1, 2, 3, and so on. Your azimuthal naman, quantum number, describes the energy subshell as well as the shape of the orbital. Okay? Start with r equals 0 and n minus 1. Okay? Where your n is your principal quantum number. Your magnetic quantum number naman is the number of orbitals in a subshell. The possible orientation of orbitals in space, no? So, it could actually be negative or positive, okay? Okay, so ang allowable value niya is negative L from your L, okay? So, where your L is your azimuthal quantum number. Okay, your spin naman, there could only be two possible spin for an electron. Could either be clockwise or counterclockwise, no? Hence, the value negative 1/2 and positive 1/2. Okay, so you remember your four quantum